Welcome! In this video, we will carefully explain Section 4.2, Direct Proof and Counterexample, Part 2, Writing Advice. We will learn how to write clear proofs, avoid common mistakes, and work through two detailed examples. First, let's outline the standard format for writing a proof. A proof is not just algebra, it is a piece of writing. We want the reader to understand the logical flow and the reasons for every step. We'll list the key rules and highlight the most important parts. Here are the standard steps. 1. Restate the theorem. 2. Clearly mark the word proof. 3. Introduce variables and what type of objects they are. 4. Use complete sentences. 5. Give reasons for each step. 6. Display important equations on their own lines. Let's visualize these steps now. Let's zoom in on two important ideas. First, the word proof signals the formal start. Second, we should explicitly introduce our variables, like suppose n is any even integer. Now, let's discuss common mistakes. These mistakes are extremely frequent, and they can break a proof even when the final statement happens to be true. We'll list the 4 biggest ones and show quick examples. Mistake 1. Arguing from examples. One example cannot prove a universal statement. Mistake 2. Using the same letter for different objects. Mistake 3. Jumping to a conclusion without showing the form. Mistake 4. Assuming what you are trying to prove. Here is a quick example of a bad proof by examples. It says, if m equals 14 and n equals 6, then the sum is even. This is true, but it only checks one case, not all even integers. Here is the variable confusion mistake. If we say m equals 2k plus 1 and n equals 2k plus 1, we accidentally forced m and n to be equal. We must use different letters like k and j instead. Now, let's do a full example the right way. Theorem. The difference of any odd integer and any even integer is odd. We will write a formal proof step by step. Step 1. Introduce variables. Suppose it is any odd integer, and b is any even integer. By definition of odd and even, we can write it equals 2 or plus 1, and b equals 2s. Step 2. Compute the difference. We have a minus b equals 2 or plus 1 minus 2s. Then we group terms. 2 are minus 2s plus 1. Factor out 2. 2 times are minus s plus 1. Step 3. Introduce a new integer. Let k equal r minus s. Since r and s are integers, k is also an integer. Therefore, a minus b equals 2k plus 1, which is the definition of odd. So the difference is odd, as required. Next, let's see how to disprove an existential statement. We want to show there exists a positive integer, n, such that n squared plus 3n plus 2 is prime. To disprove this, we prove the negation. For all positive integers n, that expression is not prime. Now factor the expression. N squared plus 3n plus 2 equals n plus 1 times n plus 2. If n is at least 1, then n plus 1 is at least 2, and n plus 2 is at least 3. So the expression is a product of two integers greater than 1, and therefore it cannot be prime. Finally, let's summarize the language. Any or for all means every single element. Some or there exists means at least one. Using the wrong word can break the logic of a proof. Here is a quick comparison table. That's the core of Section 4.2. To write strong proofs, be clear, be precise, and show every logical step. Use definitions carefully, avoid the common mistakes, and always keep the reader informed. Thanks for watching.